as you start number 90, it's going to look a lot like the last couple of problems you've done, but there's an important concept being introduced here in number 90. And the concept is introduced as you move on to the second part of this problem, because in part A that you're looking at right here, you're just dissolving the silver sulfate in water and seeing how much will dissolve. But as you move on to the other parts of this problem, you'll find that you're going to start with, instead of 0 here for sulfate, or instead of 0 here for silver, you may start with a quantity of some other, of that same ion from some other source. And so that's going to be a common ion that's added to this equilibrium. And that is going to cause a change in the amount of silver sulfate that will dissolve. And so that's what you want to pay close attention to. This is referred to as the common ion effect. And just think for a moment before we start these problems. If you already had a bunch of this silver, instead of this being 0, this was 10 moles of silver already sitting there in the solution. Well, you can see that in order for this KSP to remain constant, because it is a constant, if this is a big number, this is going to have to be a lot smaller. X is going to be a lot smaller, and so the solubility would end up being smaller. So that's what you're going to notice as you work on these problems. Now here, in this particular problem, we're given this is being just dissolved in water. So we're setting up the ice box. We're wanting to find the solubility of the silver sulfate. And in this particular case, that's just going to be X that we solve for down here, because the amount of sulfate that dissolves is going to be the same as the amount of sulfate in solution is going to be the same as the amount of silver sulfate that dissolves, the same number of moles. Now you could convert that to grams from moles if you needed to, but when we say, if you just said solubility, you can leave it in moles per liter. So we're going to come down here and say that 1.2 times 10 to the negative 5, that's the solubility product constant, is equal to the concentration of silver squared times the concentration of the sulfate. And so this becomes, let's see, 4x cubed equals 1.2 times 10 to the negative 5. So you should be able to solve that for x. And that value for x, of course, the units will be in moles per liter. That value for x will give you the solubility of silver sulfate in water. So you should have been able to calculate there something like 0.014, or 1.4 times 10 to the negative 2 moles of silver sulfate will dissolve in 1 liter of water. Now, in the second part of this problem, part B, this is the thing that's different, is we have also dissolved in this solution some highly soluble silver nitrate. So it's not just dissolved in water anymore. It's dissolved in a 1 molar solution, a 0.1 molar solution of silver nitrate. So the initial concentration of the silver in the solution is no longer 0. The initial concentration is 0.1 molar. So now after we have, we're still solving for X because X is still going to be the solubility of the silver sulfate. But this time our term for the silver, our concentration of silver, is going to start here at 0.1. Now we're still going to make this assumption, and it's not a terribly clean assumption because this is still a fairly large KSP, but it's actually going to work if you test it out. It's going to be less than 5% error, and we're going to make this assumption that 2x is really small compared to 0.1, and so we're going to drop it out of our equation. So even though 1.2 times 10 to the negative 5 is really 0.10 plus 2x squared, we're going to just ignore that 2x part of the term. And so we have 0.1 squared times x equals 1.2 times 10 to the negative 5. So this time when you solve for x, you're going to find that you're getting a much smaller concentration of the sulfate ion in solution because not as much of the silver sulfate can dissolve. So solve for x here in part B, and then go on and solve the remainder of number 90. I believe you'll find that there is a part C.